I would like to invite our first keynote speaker. So Mr. Jawad Haider is going to talk about the market overview of AI and semiconductor. So over to you, Mr. Jawad.
Thank you. And I love the idea of chai, so I can definitely use a few cups, so please keep reaching out to me for questions later. Assalamu alaikum, everyone. My name is Jawad. So thank you for the opportunity. Before I get started, if I can get a quick sense on the audience, how many here are students? Okay, so maybe about 50%. And the rest, how many are engineers? Who is not an engineer here? Okay, so just a few. All right, great, thank you. So Bilal, thank you for inviting. I see my mentor, my friend, my ex-boss, Naveed Saab here. So I'm a little bit confused now, a little bit intimidated, and a lot of other familiar faces. So let's start with something very simple. When you open ChatGPT, you open a video on YouTube, you watch Instagram. In the background, there is dozens of chips that are being used across the phone, across your mobile network, Wi-Fi network, across the data centers, all around the world, but you never see them. A few years ago, I was working on chips in Silicon Valley that ended inside millions of devices, gaming consoles, phones, cars, you name it. But the issue is that most of the times we don't see those chips, what's happening in the background. Now, today, the same thing is happening, but at a much larger scale. We know that AI is exploding. Data centers are being built at a gigawatt scale all over the world, and this is no more a company level thing. This is becoming national priority for all over the world. And what's really the bottleneck right now is not the money. That's the interesting part. The bottleneck right now is the supply of these chipsets. It's just not enough to power these huge build out that's happening all over the world. So moving on to the next slide. Thank you. So a little bit about myself. I spent nearly 2 decades in Silicon Valley. I am not allowed to call myself a veteran. That's an insider joke between Naveed Saab and me. But I spent about 20 years in Silicon Valley with Broadcom, Marvell, Semiconductor. A couple of years ago, I moved to Saudi. I was very lucky to be part of the National Semiconductor Hub. As a founding member, I see a lot of familiar faces. We put together the national framework for the kingdom, where we talk to a lot of startups all over the world, and a lot of fabulous semiconductor startups that we thought of bringing to the kingdom. A lot of them have started moving to the kingdom. We put together an incentives program, training program. We trained Saudis, 50 Saudi students. So great work there. And then later on, I joined a company called Revos, and we were building the next generation AI server chips that was later acquired by Meta in a multi-billion-dollar deal last year. And that's the kind of value that this industry can create, from deep engineering. You have one deep, great idea. Bilal mentioned about Kinara. Just one problem that you can solve, it can generate billions of dollars in values. And so now I'm leading strategy and partnerships for Intel for the region. I'm based in Saudi, in Riyadh. And so I've seen the startup world, I've seen the scale-up world, and I was also lucky to be part of the national program in the kingdom. Thank you. Okay, so this is a very busy slide, but I wanted to set the context very quickly that there is so much happening in the chipset world. And if you look at this slide, you see names like Google, Amazon, Meta, OpenAI. Now, one could argue that most of these companies are not chip companies, right? But they're all either building chips, or they're all trying to secure the supply for chips. And this is not random. There's a very clear pattern that companies all over the world, they are trying to control the compute, right? And they are trying to have as many chips as possible, CPUs, GPUs, you name it, so that you can build out the next generation of AI. Recently, just last week or probably this week, we saw that ARM, which is one of the greatest suppliers of IP, for CPUs, they themselves jumped into becoming a CPU maker, right? So there's huge things which are happening in the industry, right? Billions of dollars of money, investments, partnerships. It's almost like a circular economy in some sense, but every company is partnering with another company to, for this huge, moment that's happening in the industry. So, I have to stay here for the mic. So I wanted to, oh, thank you. So I wanted to, hello? Hello? Good? Can you hear me? Okay. So, quickly I wanted us to walk through the three revolutions, right? Like, we saw the, electricity revolution, right? I think this is not working, that's fine. So just to understand, right? So let's zoom out for a second. So we saw the first major shift in technology was electricity, right? Which ended up powering everything, right? Machines, industries, whatnot, right? Then came the internet. I think most of us sitting here, especially the young people, right? We've seen smartphones coming to life, right? Through which connected people, connected economies. And now we are entering the third phase, which is artificial intelligence. And I think there's many ways to look at these, revolutions, right? Like, but the way I think about it is after electricity and after internet, we are entering the third major, technological leap, right? And that's AI. And now, AI is not just a technology, right? This is something that's going to change everything, the way we work, right? The way we live. This is, as Jensen calls, right? So you put in energy and you get tokens outside, and that's intelligence. So for the first time, right, we can, humans can get intelligence directly out of machines, right? We can almost outsource intelligence to machines. Now, why this is relevant in the context of semiconductors, if there is no chips, there is no machines. If there is no chips, there will be no internet, no smartphones. And if there is no chips, there is no AI, there is no ChatGPT. But most, we are mostly engineers here. I think we understand that. But most people, don't understand that, every time you do something, there's a lot of chips that's involved in the background. Okay, so what does this mean in terms of the market, right? So when I was talking to Bilal a couple of days ago, so I said, Bilal, what is the audience and what can I deliver, right? And I think Bilal said that, we need to explain to the audience here the market context, right? Like what is, we're building semiconductors, there's R&D happening in Pakistan, but a lot of times maybe in Pakistan we're a little bit disconnected from the industry, from the market, right? What is happening? Bilal mentioned $800 billion market today for semiconductors. This market is slated to grow to $1 trillion by 2028. I remember we at NSH last year, we had our investment forum, and I was on the stage and I said that according to the forecast, $1 trillion would be hit by 2030. It's been pulled in by 2 years, right? So this is magical that you pull in $200 billion by 2 years. So there's a big, we're in the middle of a big super cycle of semiconductors, triggered by a few things that let's go through what are those things, right? What are those end markets and how can you benefit? So where is the demand coming from? Well, the answer is everywhere, right? But specifically in a few areas. Number one, data centers. I think we all know that the biggest build out that's happening, the biggest demand is coming from the data centers. And that's also why data centers is the highest growth if you look at the server and network here. So about 12% growth over the next few years. So I think everyone in this room recognizes that's where we should all pay attention to. The next biggest growth sector is automotive, right? Each car probably has more than 100 chips, surprising fact. And whether that's self-driving cars, delivery cars, there's going to be more and more automotive growth. The third is industrial, right? So think of industrial IoT, robotics, edge AI applications, all of that is slated to grow in a big time. And so this is what is going to make this $1 trillion industry, semiconductors, in just a couple of years. So we talked about $1 trillion industry. We talked about some of the things which are going to make that $1 trillion industry. But I really like this chart. If you think about it, there is a trade-off between when the technology is ready for prime time and feasibility for the technology in the market, right? So just give that thought a second, right? Sometimes there is technologies which Google Glass, I remember in 2013-14 timeframe, I went to Google for a meeting and they wanted to put Bluetooth in one of the glasses. It was a great product, but it wasn't ready for prime time, right? So we've seen this over and over again in the industry, that sometimes you have a technology which is great, but it's not ready, and other way around. So now the sweet spot is on the top right, where the technology is ready, and the market is also ready for it. Those are the technologies that we should pay attention to. We should try to understand what is happening in those technologies, and what type of semiconductors are going into those things. So if you look at this chart from PwC, advanced AI is on the top right. So what is advanced AI? It's, we're talking about agentic AI these days, right? ARM CPU, they announced that they have built the AGI CPU. Jensen Huang in his keynote last week, he talked about physical AI, robotics, sovereign AI, right? So I would encourage all of you to pay attention to what's happening for the future of AI. All the engineers in this room should listen to NVIDIA's keynotes and all the sessions from last week, and try to pay attention to what are the key things he's talking about. He talked about the roadmap for the new chips, right? Vera Rubin. He talked about a lot of things. It's very, very important for all of you to pay attention to that. The second big thing is humanoid robots, right? Again, we've seen robots from Japanese companies, Chinese companies for a long time. But now Elon Musk says that there's going to be 1 robot per human. Just think about that for a second, right? 7 billion humans. Sometimes some people are even saying maybe 2 robots per human, right? So we're talking about tens of billions of robots. Each robot will will have intelligence built into it. It will have tens of chips into it, right? I mean, this is mind-boggling, right? And these humanoid robots will do basic chores. You're away from your home, it can walk your dog, right? Just think about that. It can take care of aging parents, so on and so forth. So great trend to follow. And well, you know, we see some things on the sidelines. For example, quantum compute is another area where the technology feasibility is quite there, but it's not ready for prime time yet. So it's a little bit to the left. But then there is brain-computer interface, right? Elon Musk is building Neuralink, and those things, you know, the tests have started, and you know, so again, a great area to pay attention to. One of the things, you know, somebody asked me the other day that AI is taking away the jobs, and you know, where should we focus? And I think one great area, looking at this chart, is human-machine interface, right? The future, if there is going to be 10, 20 billion robots, then humans will have to really define the user experience and the user interface for the robots. And I think that's a great area for everyone to think about, you know, how to define the future interface, because humans and machines are going to be talking a lot at a different level. So, all right, so we talked about the market, we talked about the future trends. Now let's think of, you know, where the semiconductors are coming from, right? Where are these things being built? What is the future? Well, not surprising, you know, US has the biggest market share. So the x-axis is the market share, and the y-axis is the growth, right? So, and also not surprising, China is on the highest growth trajectory right now, right? They are building indigenous semiconductors in China. They're building GPUs, right? So, and so obviously we see the usual suspects, the Korea, the Taiwan, Japan. So I think this is where Bilal showed 0.002%. So that's why we're not even showing on that bubble. Hopefully, inshallah, in the next few years, you know, we show up here as a bubble, you know, as a contributor to this. Well, the good news is that the industry needs 300,000 chip designers by 2030, right? So that's a huge, I think currently the number is somewhere between 150,000 to 200,000. So everyone should think in this room, you know, how can you, sitting in Pakistan, sitting here, you know, how can you be valuable, right? How can you contribute to the semiconductor industry, you know, through obviously available opportunities in Pakistan, but also globally. All right, so a quick view on, you know, what are again some of the key things driving these things. If you look at it, there is a few themes, right? Everything in and around data centers. So that's GPUs, that's CPUs, memory, you know, interconnect, right? Everything, and you know, all the chips that go into data centers. I think you should all study. You should look at a bill of materials, you know, of what goes into a server rack, for example, right? And all the students here, especially, you know, should study each of that component deeply. You know, there's NVIDIA, there's AMD inside, there's Intel. You know, there's also a lot of startup components, right? So just study that deeply. The second piece is edge AI and edge IoT, right? A big shift is happening where the intelligence is also being brought to the edge. What that means is that, you know, you don't always need to send everything to the cloud. You know, a lot of intelligence can be processed locally, whether that's a PC, whether that's a robot, so on and so forth. Obviously, we're also going through a refresh on the 5G and the network standards, so that's another trend to pay attention to. So, you know, since everything is around AI, right, and all the future for the semiconductors is also centered around AI, it's really important to understand the AI stack, right? My recommendation is that don't think of the chip alone. I know most of the people here are engineers, and we tend to just be focused on that one small component of the chip or the specialization where you're working on, but zoom out a lot and think of, what is the AI stack? Jensen Huang recently started calling the AI stack a 5-layer cake. And I love it. I found this picture on Google yesterday. I thought it was really funny. But AI is a 5-layer cake. At the very bottom is power and energy. Right, so that's why in Saudi we have a huge advantage. Energy is cheap. There's a lot of energy. And it's a natural thing to build out a lot of data centers, because data centers need a lot of power. They need a lot of energy. Second layer up is the chips. That's where we all come in. That's where right now the biggest value has accrued, right? Think of NVIDIA, AMD, think of all the startups. So a lot of value has accrued into the chip layer. And then above that is the infrastructure, right? So infrastructure is cloud, it's data centers, right? Everything around that. All the hyperscalers, all the neo clouds. There's a new category of data centers. It's called neo clouds. I would highly encourage that you go and study what a neo cloud is. There's companies like Nebius and Lambda Labs and so on. So go and study those. Very important. Keep going up. There is models, right? Frontier model labs. Think of OpenAI, Anthropic, and even all the large hyperscalers. They're all building their own models. And finally, on the top is applications. The interesting thing is that the value almost always in a new kind of a technological revolution, the value moves from hardware to software over time. And we're going to see the same thing in the world of AI. And that's why right now, and especially in the next 5 years, chips are hot and chips will remain hot. Right? And that's the reason why NVIDIA is almost a $5 trillion company. So take advantage of that, but also understand the whole stack, right? Definitely understand the whole stack for AI so that you can bring the whole perspective back to really understand why you're building and what you're building. So interesting chart I found yesterday. If you pay attention to all the large companies, Google, Meta, OpenAI, Amazon, and if you look at the key areas where they're working on, obviously everyone is working on the models. Everyone is working on applications, but interestingly, everyone is working on chips, right? So that's really interesting. I've been told that I only have 2 minutes, so I'm going to go a little bit fast. NVIDIA is almost a $5 trillion company, so pay attention to that, figure out what they're doing. Let's spend a minute on this slide. The startups. And I think that startups are creating billions of dollars in value. Recently, a company called Grok was sold to NVIDIA for $20 billion. The company that I used to work for, Revos, we sold it in a multi-billion-dollar deal to Meta. Samba Nova, Cerebrus, all of them are building some unique chip architecture, and that's really where they're creating the value. Samba Nova is something called RDU, right? It's a different data flow architecture. NVIDIA is a GPU, right? Cerebrus is doing something called wafer scale. So just try to understand, what are the differences in these different things. Our company, we were on the RISC-V bandwagon, right? So pay attention to these startups, what type of funding they are getting, what are they building, what are the unique technology differences, architecture differences. It's very important. So finally, at Intel, these days it's not about a single product, it's about end-to-end solution. So at Intel, we are obviously famous for PCs. I see Intel Core 5 in this PC here. So we're building PC chips. we are building data center chips, and we are building chips for the edge. But the biggest advantage for Intel is that we also have our own fabrication, right? So we can also produce or manufacture chips. So that's that. And finally, I think what I want to leave you is by thinking that, Naveed Saab and I, we have, in the last year or two, we've been thinking, and, with Naveed Saab's vision, right? So we're thinking, what are the phases, right, of growing a country into a semiconductor hub? Phase one is what we are doing already in this room, right? R&D, building services companies, and trying to understand what is the global demand. Step two is IP localization and building a product in this country, right? Whether that's a basic RISC-V CPU or Pakistan CPU, whatever that means, right? And then third, eventually, is to start scaling out companies and start finding local demand, right? And I think especially in Pakistan, Bilal mentioned defense. I think defense is a huge application where we should all pay attention to in what's happening in the world. It's great to have full sovereignty and have some semiconductor sovereignty around that. So I think I'm going to end it with that. Thank you all for your time, and it's great to be here.